Okay, so let's go ahead and take a look at this problem set. First thing you're going to want to do is you're going to want to find the equation for this problem. So the rate of change is your slope. So 2,000 is your slope, and your y-intercept is 30,000 feet. We are descending, so that makes that 2,000 negative. So here's my equation. That was the first step, is to write the equation. The second step is to find the altitude after 5 minutes. So you are plugging in 5 minutes, and you are evaluating. So you get 20,000. And that is in feet. Okay. Here we are doing another equation here. So rate is $3 per day. This is a point slope equation. So y minus, 14 days, you have $68 left. Yeah. So you have a equation where you have your 14 and then your y value. So you have your rate of change, which is your slope, and then you have a point, which is like an x comma y. And so you are extracting out that in order to be able to write the equation. So some of these you could do it in slope-intercept form, and some of these should be in point-slope form. Sometimes you can get it in standard form, depending on the way that the question is worded. And so you are looking for what's being given. The first one, obviously, was being given is that you only had a rate of change and also a starting point. And remember, any starting point is a y-intercept, so where it crosses the y-axis or the dependent axis if you are looking at physics. And then here, I'm given a slope, and I'm given some information about my time and my money that's left, okay? And I do always look at the word problem to see if they're specific about what variables to use, because in the end, if you were in physics, you probably would have wanted to use, the variable t for time. You might have wanted to be a little more specific, even in this class, and say that money maybe like m, or amount, which would have been a. So you can change the variables. Be very careful when you guys look at a quiz or a test that you are identifying if there is a variable that they specifically want you to use. Okay. And then here, I've seen a couple people do things differently, but you could do just regular slope. So remember, slope is y2 minus y1 over x2 minus x1. So I could go y minus 3 over 5 minus 4 and set this equal to 3. And then what I would be doing is I would be cross multiplying. So I get 3 times 5 minus 4 is equal to 1 times y minus 3. So 3 is equal to y minus 3. I add 3 to both sides, so then I get y is equal to 6. Okay. So a couple ways that you can do something like question 7. You do want to make sure that they all have the same slope. But even if they have the same slope, let's see. So let's plot these. It is better, just to, when you don't know what you're going to do, I would plot points. So the first thing that you would want to do is you would want to see if they have the same slope. So here I go up 1, 2, and I go over 1, 2, 3. Again, I go up 2 and I go over, but here I go over 1, 2, 3, 4. So this does not have the same slope. So they do not lie in the same line. Even though like it looks like I could almost connect it, they do not lie in the same line. So this would be no, they have different slopes. Okay. This table here, we want to know if the relationship is linear. So what we have to do is we have to figure out what the slope is between all these points and then show that the slope is the same. That would mean that the relationship was linear. And then what you want to do is write the equation in point slope form. Okay. So, and then we want to figure out what does the slope represent. Okay, so 4570 minus 3320 over 3 minus 2. And remember what I told you guys before is that if you're having a problem looking at this horizontally, just write it off to the side. Do your arithmetic until you get a little bit more comfortable. Do it off to the side. So this is 1250. So my slope here is 1,250. Just do it off to the side and it's totally fine. 770 and 45. 70 over 5 minus 3. Okay, so again, if you guys are struggling, do your arithmetic off to the side. Okay, so 2,500. And then this is the 2,500 over 2. So again, if you don't know your arithmetic in a real easy way, just go ahead and do your long division off to the side. 2410. So this is also 1250. Okay. And then my last one, 10,820 minus 70 over 8 minus 5. Okay, so 10820. 70. So 0, 7, 5, 7, 3. So again, this is going to be 3750 over 3. So again, there's nothing wrong with this. If you are, struggling with some of your arithmetic, I would much rather see you do this than to go through and miss questions. Okay, so all of these are the same, so that means that the relationship is linear. So we're going to write it in point slope form. It doesn't make any difference which coordinate point you use. I just always use the first one. And it's y and x. 3320. Okay, so yes, it is linear. Because they have the same slope. And then, so I've answered the first two questions. What does the slope represent? The slope represents the change in water in gallons over a given amount of time, because it's water in gallons and over the amount of time in hours. Okay. Forester plants trees. Again, show the data is linear, and then write the equation that models the data. So 4 minus 2 over 2 minus 1. So this is 2. 6 minus 4. Oops. Over 3 minus 2, which is 2. And then 8 minus, 6 over 4 minus 3. And that's also 2. Okay, so they have the same slope, so it is linear. So I can use point slope form. Does it say anything about, it doesn't say anything about variables. I could use C and T. That would be kind of cool or kind of nice. So just for a change of pace here. I'm going to use point slope. So C minus 2 is equal to 2 times T minus 1. That's my equation. Show what the circumference is after 10 years. So C minus 2 is equal to 2 times 10 minus 1. So C minus 2 is equal to 2 times 9. C minus 2 is equal to 18. Add 2 to both sides, so I get C is equal to 20. So after 10 years, the circumference will be 20 inches. So I did have to look at the unit of measure for circumference. Okay, just looking to see what's left. Okay, yeah. So when I look at 13, what you're looking at is showing that it's a rectangle. Essentially what you're trying to do is show that opposite sides are parallel, meaning they have the same slope. And then adjacent sides are perpendicular, which means that they have opposite reciprocal slopes. I think I totally spelled reciprocal wrong. We'll just roll with it. Okay, so, because the main thing is that we do this. Okay, so let's look. I probably would like to plot these first just so that I know what I'm proving, so that I'm not just like randomly doing stuff. So here is A, B is down here, C is over here, and D is up here. Yeah. So what I'm proving is that I need to show A and B are perpendicular. That's the sign for perpendicular. I need to show that A to D is perpendicular. I need to show, hold on, perpendicular. A and B is perpendicular to BC. And I need to show AD is perpendicular to DC. And then I need to show DC is perpendicular to BC. And we already did BC to AB. Okay. So then I also need to prove parallel. So I need to prove A to D is parallel to BC. And I need to prove that AB is parallel to DC. Okay. By finding slope. Okay, so we need to find the slope of AB. So we're going to find all these different slopes, and then we'll just use them to prove that it's true. So A to B is -2 minus 3, -1 minus a -3. So this is -5 over 2. Okay, and then B to C will be 0 minus a -2 over 4 minus a -1. So this gives me a 2 over 5. Okay. And then C to D, so DC is 5 minus 0 over 2 minus 4. So this gives me 5 over -2. And then the last one was A to D. So 5 minus 3 over 2 minus a -3. So this gives me 2 over 5. Okay, so what are we trying to prove? So A to B is perpendicular to B to C. A to B is -5/2 perpendicular to BC, yes. And then AD is 2 over 5 perpendicular to DC, which is -5 over 2, yes. And then DC, which is -5 over 2 perpendicular to 2 over 5, yes. And then A to D is 2 over 5 parallel to BC, which is 2 over 5, yes. And then AB, which is -5 over 2 parallel to DC, which is -5 over 2, yes. All right, so I proved that they all have the same, they have same slope when it's parallel, opposite reciprocal slopes, meaning one of them is positive, one of them is negative, and their fractions are flipped. That is opposite reciprocal, okay? All right, so that's it for this section.